Question 14. So let's start by thinking about how we could possibly combine these things together. So let's rearrange them. So x minus 3 and divide 2. So that equals sine t. Let's have a look at this one here as well. So if we go y minus 4 divide 2 equals cos 2t. Now we should know, so cos 2t is equal to 1 minus 2 sine squared t. So y minus 4 over 2. Now I'm trying to think, right, okay, well, wait a minute, I've got sine t over here. Well, what happens if we square both sides? Let's square both sides. There's another clue here, look. X minus 3, and look, x minus 3 squared, okay? Remember, sometimes when you've got to show that, sometimes there's a bit of a clue up there. So if we square both sides, get x minus 3 squared over 2. So let's just have a look now. What we can do is we know sine squared t is this. So let's just pop it there and just rewrite this part. So what have we got? We got y minus 4 over 2 is 1 minus 2 multiplied by x minus 3 squared over, oops, I forgot to square that bit, didn't I? That was nearly a mistake. There. So it would be over 4. Near disaster. Right, okay. So we're obviously going to cancel that there. Maybe I was just thinking ahead. And if we multiply both sides by this 2, we end up with y minus 4. And then we've got 2. Take away, and then we're going to have, so we're multiplying this by 2, so we've got a 2 underneath, so that's just going to be x minus 3 squared. Add the 6 to both sides, and we've got what we were after. Right, fab, there you go. Right, so it's a good start. Now, part B of the question says sketch the curve, right? Sketch this curve here. So let's have a little look, see what that's going to look like. So now we know that it's going to be, so x minus 3, it's minus, right, here we go, going to be minus x minus 3. So that means it's going to be a curve, going to be unhappy. 6 is going to be the maximum point it's going to go to. I just need to think about, wait a minute, x minus 3 squared. Well, if I said draw x minus 3 squared, that would be coming like that. Remember, it gets moved 3 places to the right in the positive direction. So we're actually going to be up like this here. Now, I'm just going to do these bits here a little bit fainter there, because a little bit more to be said about that, because these 2 points here are actually important to the next part, right? So if I draw y equals 6 minus x minus 3 squared, that's all of that. But looking at part 2 of this, if you think about it, when we look at these 2 things over here, not so much of a problem for y, because the maximum y could be is 4 plus 2, because cos 2t, the maximum that could take is 1. But look at this, the range of x, just thinking about what x could actually be, because the maximum it could be is 5. So the maximum x could be is 5, and that would give me a y value of 2, and the smallest x could be, so if this was minus 2 here, would be 1. So we actually have a slight limit to what it could be. So it's actually the limiting factor is the domain is limited, and it's limited for x between 1 and 5 for that reason. Right, now let's have a look at part C. So let's think about part C here. What are we told? Well, in the question it says state the range of values of x when, okay, so we've got a line with equation x plus y equals k. Right, okay, so x plus y equals k, and it tells us k is a constant, intersects c, so intersects this, our curve, at 2 distinct points. Now, x plus y equals a constant value must mean our line's going in this direction. Right, it's got to be going in this direction just here. So therefore, the lines, if remember, it can only go to these 2 points here. So the line may well go there. Great if it goes there. But the furthest it can come down is through this point just here. Just here. So the first thing that we can say is that, so at this point 5, 2, so if I substitute in 5, 2, then what I can say about k is that that's got to be above that, hasn't it? It's got to be above it. So we can instantly say that k must be more than or equal to 7. So that's our first point. Now the next thing that we're going to do is, quite simply, let's just take this, and a number of ways that you can approach this, but I think this is probably easiest, is that if we just rearrange y equals k minus x, and then just combine it with our c. So c was 6 minus x minus 3 squared. And it was y equals, wasn't it? So let's just sub in that. So if we put in that equals there. Right, let's see where we go with this. So if I multiply this out, what do we get here? We can have 6 take away x squared. I'm jumping a little bit here. We're going to plus 6x minus 9. I've kind of removed the brackets there. A little bit dangerous doing that. Add x to both sides and take away k. So we're going to get minus x squared plus 7x, and then we're going to have minus 3 minus k. Now, if we know it's got 2 solutions, then remember b squared minus 4ac must be more than 0. So a equals minus 1, b equals 7, c equals minus 3 minus k. So if I sub that lot into here, that's going to give us, what's that going to give us? 49 take away 4 multiplied by minus 1 multiplied by minus 3 minus k. That's got to be more than 0. So where's that going to take us? So if I multiply this out, simplify this, it's going to give me 37 minus 4k. I've jumped a little step there, okay? I'm sure you can do that. Add 4k to both sides, so 37 adding 4k, divide by the 4, so k has to be less than 37 over 4. So we've got our 2 points here. Now, don't lose the mark here. It's really annoying to lose this mark because the question did say leaving your range of values of k in set notation. So all we've got to do here, let's just write it down. There's that. little squiggly bracket, and it's going to range from 7, so k must be more than or equal to 7, and it's got to be less than 37 over 4, and hooray, we are done.